I mean, I could bring this up when I was talking to a person from Europe.
What?
Probably bring this up when coming come from Europe, I was like, what do you mean? I only know the measurements for virgins.
So chapter 4 is on convergence. This has more than just conversions. This is the inside covers of the book. There are some tables here, like the table on the front page. The table on the second we'll use, it covers prefixes. And this thing is missing a page. Why do I only have 3 fucking pages? I'm guessing one of them has an extra page. Ah! I done fucked everything up.
How many pages of this book?
There should be 4 pages.
Uh-huh.
If you don't have 4 pages, get 4 pages. Come up and get another one if you don't have 4 pages. I apparently, when I'm gonna blame this on Bertha because I was stapling last year, didn't I? I had the 2 tables next to each other, but now they're not next to each other. Page 4 is the other one. With most of the things, that's got all the conversion factors. We're gonna look at that first. That should have been the first page.
The last page should have been.
Yeah, it doesn't. They're all there. You can use them in any order. So what we're doing, that conversion bridge we just talked about, we're doing the conversion bridges. In this chapter is all about conversion bridges. So, and use this on the homework. I will give you what you need with this on the test. You do not need to memorize these things. Some of them, hopefully you do memorize over the course of the class if you don't know them, like inches in a foot, you should know. Since you do live in America, you should know our units, but the conversion between like meters to feet, no. Shit like that. So let's look at conversions. And I'm going to reference this too because I don't know most of them as well. How does a good conversion thing go? Let's start with distance. We were doing distance earlier. Let's start with distance here. So like in America, we got inches, feet, because I know how to speak. Inches, feet, miles. We also have something called the yard. And let's say I start off with, how long is a marathon? 26.2 miles? I think a marathon is 26.2 miles. I think. I'm making this shit up if I'm wrong. Marathon, 26.2 miles. How many feet is that? And we're going to ask how many inches. In fact, let's start off with inches. Let's do the inches first. Because it will teach more this way than going the other way. In the interest of saving time, this seems like the best way. You wouldn't do this in real life, you do the feet first, but I think to teach it. So if we look at the table, we want to start with 26.2 miles. And I want to end with some unknown value in inches. It doesn't matter, it's 26.2, right?
Yeah.
So I have inches to feet. And I have MF. I've got inches to feet right there, and I've got feet to mile. I don't have miles to inches though, do I? So I might have to make 2 bridges. The one thing I do have with miles is I have feet. So let's address that bridge first. Let's get rid of what we can. We want to get rid of miles. The only one I got there is 1 mile is 5,280 feet. And so if I do that, the miles will cancel. I throw it over to them. I didn't get where I wanted to go. I have feet still. And if I want to go from feet to inches, that's the top one. 1 foot equals 12 inches. I'm trying to get rid of feet and end up with inches, so I'm going to use that to guide me on what goes on the top and the bottom. Feet and inches, and we've got 1 foot equals 12 inches. I can cross off feet now because they're on the top and the bottom. Because remember, we're treating this like a fraction. So what we're going to do is treat these all like fractions. This is 26.2 over 1. This is 5,280 over 1. And this is 12 over 1. And we're left with inches. That's the only unit we have left. With fractions, we multiply top and bottom together separately. This is not what I'm doing in my head.
No.
So, how many inches do I get?
1,660,000.
Did anyone else get that? That's how you, that's what you read to me. Is that the number you see? Okay.
I was making sure I was saying it correctly.
So,
So the easiest way that I like to look at it is just crossing out all the ones, or going ahead.
We don't even
or
need the
you
ones,
don't do
right?
that. Yeah, you don't need the ones, or what you could do is just since it's all multiplication, you can go and multiply all the ones that are at the top and then divide them all by 1. But since you know it's divided by 1.
Go ahead, Bertha.
so this is the miles we were trying to convert. This is
And we want to end up with
in
inches.
1 mile.
Yes.
And why are we going?
We wanted inches. That's why I said, let's do inches first. I start off with this longer bridge. We could have stopped at feet first. If you had stopped at feet first, we would just have that.
First and then. Okay.
The idea is you may not always want to do that.
Yeah, if you stopped at feet, you'd end up with this number,
Okay.
which wouldn't be the right answer because this would be 1,038,
And
whatever.
then you
the
change
feet.
that to.
And then you change that
inches,
to-
Right?
Yeah.
Could have done that too, okay?
Yeah, and that's how I do it in my head, that's probably how most people do it, but the conversion.
So what was the sub answer?
It's 138,336.
138,336.
Yeah, 336
And that's miles or feet.
feet.
And then we do that value with one more bridge. This is feet, feet on bottom, 12 inches on top. And we should still get the 1,660,032 inches.
And you will, because that's how I actually did it. I didn't do it how you originally showed you. Because it's feet and because it's easy, it's pretty easy to think the way we're thinking, but when you start working in like chemistry. There's no way you can start going from moles to like atoms and moles.
Just-
You really have to use that conversion.
It's pretty helpful to stick with this, especially like when
Physics too.
we're gonna do liquid volume in a second. We're gonna go from gallons to teaspoons. Because it's on here. There's conversions to each step of the way.
And what he's showing us makes it way easier because you can just you can just think about the entire problem. And once you have the entire problem thought about, then you can do the calculation.
So in a calculator, I can do 26.2 times 5,280 times 12 equals. And it'll spit it out.
I just wanted to make, understand what.
So you can do it in parts,
You can do it,
you can do it in parts, or you can do it all at once.
no, you're eating.
And when you show the teaspoon thing, it would for sure show why you want to do it all.
This also, doing it also one and all at once also helps avoid rounding errors. You only want to round once.
And sometimes you'll get put with like a weird decimal and it's like a for infinity decimal and you're like, oh. And then you're never gonna get to that.
Right. So there's two ways to do this. This is the all at once approach. Above that red line and below it is doing it piecemeal, one step at a time.
I guess a tricky part is gonna know. Doesn't matter the order, what if I put the 12 first and then the 5 to 80 second? Doesn't matter, right? It's the same.
In terms of the multiplication, no.
Oh, but
In
when
terms
you're
of the
beginning-
thought pattern, it's harder to think that way. Cause like here, you don't always know what they're gonna be. So like just following the chart and going, okay, I've got feet to mile, I can at least get rid of miles that way. And I've got feet, and then I can go feet to inches. So it's easier to follow the pattern where you're getting rid of the thing on top in the very next bridge. But it does work. You can go in any order. I think my head would blow up if I tried to do it like that. Because like that is not logical to me. But if you can do it, like you know where I know where I'd be going. And the math is probably easier doing the times of 12 first. So you can multiply them in order. Let's take a look at another one. So we got both answers there. We figured out how many feet it was too. So we had feet and inches. Let's go with, oh fuck it, let's just go straight to it. How many teaspoons in, oh fuck it, let's make it fun, 0.78 gallons of milk?
You know, order
I think.
I think you missed the metric. Of course, if it's a tease.
Okay, so what do we have? We're starting with 0.78 gallons. And what do we have here? Gallons goes to quarts. And I don't see anything else here that says gallons. So I'm gonna throw gallons over. And I'm gonna pick up quarts, and it's showing me the abbreviations on that. That's pretty handy. And it says 1 gallon to 4 quarts. And that gets rid of gallons. And I'm not where I want to go. I want to end up at teaspoons. And so the only thing I have here that shows quarts is the quarts to pints. So the next one is quarts, go to pints. Yeah,
When you do, once you do for the liters, and then you go to liters and milliliters.
I'm not, what?
Couldn't you just go?
Do you know how milliliters convert to teaspoons?
It says it right here. 1 teaspoon equals 4.3 milliliters.
We'll do that later. I'm keeping the same units for now. Same unit system. There is 1 quart is 2 pints. And my quarts go away now. And 1 pint is 2 cups. We'll do that next. And then it says 1 cup is 8 ounces. This is a long bitter age, isn't it? Cups go away. And ounces go to tablespoons. 1 ounce is 2 tablespoons, which is a big T. And finally, 1 tablespoon is 3 teaspoons, which is a little t. This is some bullshit. Those are not the abbreviations for tablespoon and teaspoon. Tablespoon is TBSP. Teaspoon is TSP. I don't know why they're doing this bullshit lazy shorthand. Oh, that one goes down there. Big T and little t, you fucking liars. They have the B in there because tablespoon, and the word table has a B in it. That's how you tell the difference between table and teaspoon. All right, so I can write this as a lot of fractions multiplied together.
Or you could look at it.
Now, since the bottom is all 1, 1 times 1 is just ones. I don't even need any of the bottoms at this point. The only time you really need something on the bottom here with the multiplication part is if there's something that's not a 1 on the bottom. And I'm sure that's going to be the case when we do it the other way.
Yeah.
So what does this end up being? You gotta get your calculator going. 16 times 16 is 256 times 3 is 768 times 0.78.
Easily.
What is it? 0.04. Can anyone confirm that? It seems right. 768 times 0.78 should be around 600. And that's in teaspoons. Okay, so while people are still verifying that, let's talk about the route Mason was looking at, and I think he grabbed
I was just looking at the first sheet.
the front page. The front page has, what do we have here? It's got gallons.
I didn't even do gallons. I just knew that there were
4 quarts in a, there's 4 quarts in a gallon, and if there was 2 pints to a quart. I just knew that there were 8 pints in a gallon. So I just went from there.
There's a couple ways to go. I think switching to
I just went to
pints is easiest,
Yeah,
but. We could follow that route entirely, or we can switch around. Notice, if we on the first page, I can go from gallons to cubic meters. And then cubic meters shows up right here, cubic feet,
I don't like that though.
and I don't like that either, because cubic feet to cubic inches is a little like, where am I going here?
Yeah, it's too much thinking.
Yeah, there's a lot of work going on there, so. Because there's no written table for cubic feet to cubic inches, and I can figure it out, I know it means 12 times 12 times 12, but that's more work. So why don't we switch to quarts or pints? And to switch to pints, we still need that 4 quarts to a gallon. And we still need the 2 pints to a quart.
Oh, I'm not wrong myself.
You jump to the 8th, but not everyone knows that it's 8. And I don't want to jump to the 8th. So now I've got pints, and pint shows up as 0.47 liters. Which is a big L. And I can see 1 teaspoon is 4.93 milliliters. Which is not what I have liters. So we need to do this, we need to talk about the metric system.
Is it 100 or 1,000?
It's 1,000.
But it's 1,000. Milli is 1,000.
And it's on one of these tables here. On page 2, the metric prefixes.
Yes, centi is 1,000.
Milli says 10 to the negative 3. So 1 milliliter is 10 to the negative 3 liters.
Oh, why'd you do that?
What?
Why'd you do that?
You're the one that fucking wanted to use,
Why'd you write it like that? Why didn't you?
because it's what's on the table.
Oh,
So what 10 to the negative 3 means is, if you don't want to use that, we start with 1. And 10 to the negative 3 means move the decimal left 3 times. Left comes from the minus sign. So I'm going to go 1, 2, 3. And that would give me point, and then I got to fill in these spots that didn't have a number with zeros. 0.001. Instead of writing 10 to the negative 3, I can write 0.001.
but at least now you can't do it.
And that seems like, it seems like a really weird way to say that.
Yeah, but now I just like it that you can't ignore it. You can actually.
Right. Another conversion that works right there is 1,000 milliliters equals 1 liter. That can also be put in right there.
However, if you want to keep the flow of the chart the way you have it, we've got it.
Well, this would keep the liters, dumping liters, keeping
Oh.
milliliters on top.
Oh, yeah, you're right.
But that just doesn't show up over here. Do they have that anywhere in here? Oh, they've got the 1 milliliter is 0.001 liters here too. That shows up on the conversion factor page. So we didn't need the 10 to the -3, we could have gone to this part right here. So, I'm gonna, like, I've dumped a lot of shit on the way. So I'm gonna rewrite what I have in terms of the fractions. And it's all gonna be in teaspoons. When I condense this down, I wouldn't put this in a calculator like this. I would only put the things that are not ones. Now, I'm sure there are rounding errors in this. Because I doubt it's exactly 4.93 milliliters to a teaspoon. So I didn't bring my regular calculator here, so I will use my cell phone. Oops, I got too many. Divided by. And here I'm getting something's off. What is off? .78, I've got the 4, I've got the 2. Oh, I put the wrong number up here. That means I got the wrong number right there. And so when I do this, I'm getting 594.88. 4381. Two decimal places like above. This is 594.89 teaspoons. These are different values. Not the same. And the reason why is called rounding error or precision. It's related to precision and significant figures, which we will cover significant figures in chapter 5. The idea is each time they did this thing like here, like 1 point to 0.47 liters, it probably wasn't 0.47, it was 0.47 and something else. And they rounded to 2 decimal places. And by rounding to 2 decimal places, they introduced error. And then this happened again here. We had more error here. So we had 2 sets of errors, and the errors compounded to the point where it made a 5 teaspoons isn't a lot of difference, but it is like almost 1% off. So you're better off not switching systems if you can avoid it. We have 2 major systems in the world. We have the International System of Units. Known as SI. And we have the United States units. I'm pretty sure every other country in the world uses SI. And then along came the Americans and said, you know what? We know you got your kilometers and your meters and shit, but we're not gonna measure that. We're gonna use something called feet. And fuck it all up. And cups. Who came up with gallons and cups and quarts and pints and? One of these is vastly superior to the other. And unfortunately, it's not the American one. SI is a much better system. And so, and there's rules. Why? There are rules. When I want to go from inches to a foot, I got to multiply by 12. That starts leading to some fucking weird numbers. In the SI system, everything is a multiple of 10.
Which logically makes a lot more sense.
It's just doing the math is easy. It's just shifting the decimal point.
Yeah.
So like they don't use miles. No, they don't use miles. They use meters is the base system. And something that's close to a mile, but is a different value is called a kilometer. Their base is meter. This is called the base unit. That shows up over here too. And we have a prefix. Kilo. So there is several ways you can look at it. The common one is looking at the metric system chart. The ones you will see most often are kilometers, which is 1,000 meters. And it goes by km. So one kilometer is 1,000 meters. And then what shows up on rulers? Rulers, I guess, show decimeters, but really it's a meter stick and it goes with centimeters and millimeters. Centi is like our percent. Percent, centi. They both have cent in it. It's got that base cent. It means 1/100. So 1 meter is 100 centimeters. Or 1 centimeter is 1/100th of a meter.
For medication though, here they do use milligrams and.
Yes, grams is a unit of weight. So right
So
now, this is just, there's different ones to use, but the prefixes remain all the same. You go milligrams, there's micrograms. We'll cover micro in a second. That's an excellent point. We do dosages in milligrams. You see those in American stuff. And you'll see cc's and milliliters and stuff like that.
Have you become a nurse? You better.
Yes, I think
Because I feel like.
that the medical world said, no, fuck you, America, you're not coming up with your own shit. Because otherwise we're gonna start killing patients because we're not converting right. But we'll get to that. So these are all distance measures. So kilo means, oops, just one L, means 1,000 times the base. Centi is 1/100th of the base. Milli, these are the common ones you'll see, is 1/1000th of the base. How the metric system is superior is, let's say I've got 2.3 meters. M is for meters. If I want to go to kilo, if you want to go up in size where it's 1,000 of these is 1 meter, you got to move it to the left. 1, 2, 3, count the zeros, 3 zeros. I'm going to move it left 3. So I will have 0.0023 kilometers. The other way of figuring it out is that I gotta move it left is the other way of doing this is rewrite these as the base. If I've got kilo equals 1,000 times the base, I can get base by itself if I just divide both sides by 1,000. So base is 1/1000 kilo. The same thing happens with centi. If I want to get rid of centi, I have 1/100. I can multiply both sides by 100. So 100 centi is 1 base. And you do that with milli, you get 1,000 milli is 1 base. And base is it works with meters, it works with liters, it works with grams. Whatever unit that you're working with in the metric system, these are all just multiples of them, which means moving the decimal point. If you're doing the conversion bridge, these work just fine. Or you can use the things listed here. This says 1 kilometer is 1,000 meters. Or we can do 1/1000th of a kilometer is a meter. So it kind of works both ways. The main ones in the metric system that are different than the US are length, which they do in meters. They do weight is in grams. And they do volume, which is in liters. Thankfully, they still measure time the same way. Or we measure the same way as them. Like they're like, no, we're not gonna fuck up the clock. That's too much work. We did fuck it up with daylight savings though, because that's what we do. We like to make shit American, so we're fucking with it. So, let's do that 2.3 meters. One way of using it with the bridge, and to show you that you get that same kilometers thing. I want to get rid of meters and I want to end up with kilometers. The table here tells me 1 kilometer is 1,000 meters. So I have 2.3 divided by 1,000 kilometers. And that's going to give me 0.0023 kilometers. Dosages often are in micrograms. Doses in medicines are often in micrograms. And we tend to see it on bottles as mcg. But everywhere else in the world writes it as this. This is called mu. This is the mu symbol. MC is the abbreviation that we use in America for micro. There are 1 million micrograms in 1 gram. G is for gram. Which means 1 microgram, if I divide both sides by 1 million, 1 microgram is 1/1 million grams. I've got 6 zeros. So we're going to do shift 6 places. And which way we go, it depends on whether we're going up in size or down in size. If you start at the base and you want to go to smaller sizes, we are multiplying by that number, which means shifting right. Shift decimal right. So like going from base to micro has 6 zeros, shift the decimal plate right, or shift the decimal point right 6 times. If you want to go to the bigger sizes, like kilometer or something like that, giga, you'll see on the metrics prefix list, there's mega, giga, tera. If you've ever looked at computer shit, that should sound familiar. Megabytes, gigabytes, terabytes, they do it off that same numbering system. Base bigger units, we shift left. So if I want to go from base to kilo, kilo is 1,000. It's got 3 zeros. We're shifting left 3. Some examples of this, like B12. B12 pills often come in like 5,000 micrograms. How many grams is that? If I want to go to grams, I start with the 5,000, the decimals here, and micro is the one that has 6 zeros. So I'm going to shift it left 6 times. It's 0.005 grams. Not very much. A gram, I saw this in the book today. I was looking through the book, like they give some neat examples, like the weight of 2 large paper clips is about 1 gram. So like grams are pretty light. The width of a large paper clip is about 1 centimeter. So that was like, if you had like a large paper clip, it's a good way of doing it. So we'll do some more on this on Wednesday. I think I've flooded your brain with enough shit for today. Please get signed up for homework on the MyMathLab if you've not. Go through your email, find the code. Don't fall behind. And I will see you on Wednesday. Thank you, Mason. You were good today. Not too much.